Welcome to Easy Math TV. We are continuing our series on descriptive statistics, and we're going to close out our unit on descriptive statistics with another one more continuous distribution, and this is the one that's based on the normal. This is called the normal distribution. So you can actually see a graph of it down here. We're going to talk about that in the second video because it's going to take two videos to get through this, I think. And you can see the shape of the curve here. So this is no longer a uniform, nice, straight, uniform distribution. This is called the bell curve. And I don't want you to be afraid of it. There's nothing to be afraid of. Um, we're going to be using Excel, though, to calculate probabilities of normal random variables. So we're starting with a normal random variable x, and we're going to be given what the mean of that random variable is. The mean is mu, because that's a population mean, and the standard deviation is sigma, because it's the standard deviation of the population. So what x, just to make it a little more meaningful to everyone, x represents the average retirement age between any two individuals who have already retired. So we choose two retirees and we ask them, at what age did you retire? Okay. And that could be a whole number, by the way. So like that could be discrete. And they're going to tell us what age they retired at. But then we're going to calculate the mean, the average of that. So that's no longer discrete, that is continuous. So X is the average retirement age between any two individuals selected at random. And we know for a fact that X is normally distributed with a mean of 65 and a standard deviation of 4.24. Okay, so mu is 65 and sigma is 4.24. So the way that we're going to be approximating the probabilities is we have to create a grouped probability table. And it has to be grouped because we can't list the individual values of x. Remember in our last video when we talked about continuous uniform distribution, we mentioned that we can only calculate probabilities on intervals of x, not individual values of x. So you can see in column A, and it spills over into column B a little bit. So I left column B blank so that we could read these intervals. But these are going to be the intervals that we're going to use. And so you might be curious, how did we calculate the upper and lower limits of those bins? So that's what we did up here in row 4, okay? So I gave you a little bit of a visual aid to help you here, but if you're doing this on your own, you really only need to be typing in row 4 here, okay? So don't worry about the other stuff. And what I want you to notice is that the mean is in the center of our data, of our list of numbers. So starting with cell H4, so move all the way over to H4 and just type in the 65 there, okay? That's the first thing that you're going to do. And I've actually labeled it with mu underneath so that we know that that is our center. That is the center of our data. That is mu, all right? And we're going to choose a bin width of basically half the value of sigma. So my bin width was just 4.24 divided by 2, which is going to be 2.12. So basically that's measured in years. X is a retirement age, right? So these are numbers in years. So at the center is 65, and we want to add to that to get to our next number. We're going to add 2.12. So I want you to notice that in cell I4, we're going to type equals H4 plus 2.12. All right? It equals H4 plus 2.12. And just hit enter. And then if you fill across, you'll notice that every time you move across, you're going to see that it's going to take the cell to the left of it. So in cell J4, it's going to take I4 now and add 2.12 to that. So every time you move further to the right, you're taking the previous cell and adding 2.12. So as we go, we are increasing our retirement age a little bit each time. So the further up we get, the the less likely it is. So like, the vast majority of retirees are somewhere in this within this range of 65. But if we go all the way up to 77.72, there are people that just don't bother retiring at all. I mean, I imagine that there's people who just never retire, and there's people who wait until they're 80 to retire, or 85 to retire. And so, like, you've got those rare people up here, and then to the left, so down here in cell G4, you're going to subtract 2.12 from the mean. So that's equals H4 minus 2.12. And then if you click on the anchor and drag that to the left, you'll see every time we move a little bit to the left, you take the cell just to the right of it. So in cell F4, you would type equals G4 minus 2.12. So the further left you go, you take the number just to the right of it and subtract 2.12. So there's kind of this mirroring that happens when as you're moving to the left, you are subtracting from the number just to the right. So in cell E4, we have equals F4 minus 2.12. So again, you can just fill that across. And don't worry about color coding. The colors you see here are based on how many standard deviations away from the mean we are. So anything in green is within 1 standard deviation of the mean. Anything in blue is within 2 standard deviations of the mean. And anything that you see in purple or pink is within 3 standard deviations of the mean. So basically, the further out we go, the color changes. Okay, the color changes. So each of these numbers is labeled according to how many standard deviations away from the mean it is. So mu minus 3 sigma is 52.28. We can verify, let's just check that one thing and see for a fact that that is in fact equal to that. So if we start with 65 and subtract 3 times our sigma, which is 4.24, we get 52.28. So 3 times sigma away from 65 is 52.28 on the left. And then on the right, 3 times sigma to the right of 65 is 77.72. So that's where all of these numbers are coming from. We just keep either adding 2.12 or subtracting 2.12, okay? That's going to give us the starting and ending points for our bins. So you can go ahead and pause this video if you want. Go ahead and pause, and in your Excel spreadsheet, complete this row, complete row 4, and then complete column A, which this just needs to be typed in. There's no formulas here at all. We're just typing these in. So the first bin is everything to the left of our first number, 52.28, because there are people that retire as young as 40. So, we don't have a minimum here. So we have to, our first bin is just anything to the left, anything less than 52.28 is going to go in that first bin. But you'll notice look at the second bin here. The second bin literally goes between our first 2 numbers that we have written down in B4 and C4. So it starts at 52.28 and goes up to 54.40. But I typed that whole thing in column A. It just spilled over into column B because it's too wide for that column. Okay. I could have stretched it out, but I'm not, that's not a big deal. You could do that yourself if you want to. So basically, set up all of your bins. Your last bin is going to be down here in row 21. It's going to say greater than 77.72 because that's our last value. But there is a small, tiny, tiny chance that someone could have retired at an older age than that. So, so we do have to include a bin for greater than 77.72. But the one right before that was from 75.6. You notice those are the two numbers in pink. From 75.6 up to 77.72. That's our last bin here. And then we also have a bin from 73.48 up to 75.6. And that's these two numbers here. 73.48 up to 75.6 is another bin that's going to be in pink. Okay. I've color-coded them deliberately because there's going to be certain percentages of values that fall within those ranges, and that's unique to the normal distribution. So get that set up, and then we'll come back in the second video. We will complete the rest of this table here, and we're going to talk about how to calculate probabilities of outcomes. Like, subscribe, comment down below, share these videos with other people if you think that they might find them useful. I'm trying to explain concepts here, so like you won't see some of what we're discussing in other videos, and I'll see you in the next video.